Now that we have done in a previous example how to compute cosine of tan inverse of 3x minus 1, I wanted to go through this example in a slightly different way that is very frequently used. And so I have written some of the solution that we had before, that we defined tan inverse of 3x minus 1 to be phi, and we're trying to figure out what cosine of phi is. And we use the inverse function to say that tangent of phi is 3x minus 1, and phi is between minus pi over 2 and pi over 2. And I guess technically I should not put these equals because tangent is not defined at negative pi over 2 and pi over 2. So another way that you can go about doing this type of problem is by constructing a triangle with an angle phi and then determining cosine phi. And let me show you how that goes. So I know that tangent phi is 3x minus 1. And so if I draw a triangle here with an angle phi, I want to draw this triangle such that the tangent of this angle is 3x minus 1. And it may help when you do problems in this particular way to rewrite your right-hand side as a fraction. So if tangent of phi is 3x minus 1 over 1, remember tangent of an angle is opposite over adjacent. So that means that this opposite side is 3x minus 1 and this adjacent side is 1. So this triangle that I've drawn is a triangle such that tangent of phi is 3x minus 1 over 1. Now keep in mind what we're trying to determine. We're trying to determine cosine of phi. If I want to know cosine of this angle phi, I need to do the adjacent, which is 1, divided by the hypotenuse. But I don't know the hypotenuse, and maybe I should have clarified that this should be a right triangle. Since this is a right triangle, I can determine the hypotenuse by the Pythagorean theorem. It's interesting to me that you can do these problems in slightly different ways, but it always comes back to the Pythagorean theorem. Okay, so let's figure out what this hypotenuse is, then we'll be able to determine cosine of phi as the adjacent side divided by the hypotenuse. And so the Pythagorean theorem says that 1 squared plus 3x minus 1 squared has to be equal to the hypotenuse squared. And so solving for the hypotenuse, you get that this is going to be plus or minus the square root of 1 squared plus, and then you have to FOIL this or distribute this, however you want to phrase that, just like we did in the last problem, 9x squared minus 6x plus 1. And since the hypotenuse is a length, we'll select the positive. And so this ends up being the square root of 9x squared minus 6x plus 2. And from there, once we have the hypotenuse, we can figure out what cosine of this angle is. It's going to be 1 over the hypotenuse. And so cosine of our angle phi, which is, well, that's what we wanted to figure out, right? Cosine of tan inverse of 3x minus 1. That is going to be 1 over the hypotenuse, so 1 divided by the square root of 9x squared minus 6x plus 2. Now while this is a very common way to approach this type of problem, cosine of tan inverse of 3x minus 1, I prefer to use the other method. And to see the reason why, let's just imagine that we were doing this other problem here, cosine of sine inverse of negative 1/2. We got to a point where sine of theta was negative 1/2, and at that point, we would, if we wanted to do this using a triangle, we would try to draw a triangle for which sine of theta was negative 1/2, but that's not entirely clear what that means. You can make sense out of it. Having a triangle with negative lengths is somewhat confusing. And something that can be even further confusing is with the method that I have shown you, the angle theta can be between minus pi over 2 and pi over 2. However, when you have a triangle, all the angles, or at least a right triangle, all the angles have to be between 0 and pi over 2. So theta is not allowed to be negative when you're drawing triangles. So in other words, the method that I showed you here in these examples, I would say it makes a little bit more sense for more types of problems, especially when you have negatives that make the problem, if you were to draw a triangle, not quite as clean. Somehow you have to make sense of negative side lengths, and you have to make sense of, or not even make sense of, you just cannot have angles which are less than pi over 2. Sorry, not less than pi over 2, less than 0. You can't have negative angles in a triangle.